Definition. Consider three vectors u, v, and w. The triple scalar product of these three vectors is u dot v cross w. Notes and properties. 1. The triple scalar product is a real number and not a vector. U dot v cross w is also denoted by determinant of u, v, w. The triple scalar product is null if the three vectors u, v, and w are coplanar. Example. What about the determinant of the three red vectors? Take 10 seconds to think about it. In fact, the vector ch is equal to the vector be, so the three red vectors are coplanar, so their determinant is equal to 0. Now what about the determinant of the three blue vectors? Take 10 seconds to think about it. In fact, the vector fh is equal to the vector bd, so these three blue vectors are coplanar, so their determinant is equal to 0. Special case: if two of these three vectors are collinear, then determinant of u, v, w is equal to 0. Example. While finding this determinant, we notice that the vectors AD and GF are collinear, so the determinant is equal to 0. 4. If determinant of u, v, w is positive, then the system u, v, w is a direct orthonormal system. Given three vectors u, v, and w in an orthonormal system, then their triple scalar product is given by this determinant. The first line contains the coordinates of the vector u. The second line contains the coordinates of the second vector, which is v, and the last one contains the coordinates of the vector w. To find this determinant, we write down the first element A, then we hide the corresponding line and column. Then we take the remaining determinant and we multiply it by A. Then we put a minus preceding the element B and we repeat the same procedure. Then we take the element C and we repeat again the same procedure. And then we compute this determinant. Here is an example where we find the triple scalar products of u, v, and w. The determinant obtained is equal to 0, which means that the three vectors u, v, and w are coplanar. Applications. 1. Volume of a tetrahedron. V is equal to 1 over 6 determinant of CB, CA, CD. Note that you can take any three sides such that the vectors be non-coplanar. Also, V is equal to the area of a face times height over 3. Example. V is equal to the area of ABC times DH over 3. Here, We should note that when we take the area of a triangle, we should multiply it by the height that is perpendicular to the plane of this triangle. Volume of a parallelepiped. V is equal to 1 over 6, determinant of AB, AE, AD. Here also, you can take any three sides such that the vectors be non-coplanar.